Okay, let's talk about what are the various clustering options. So basically there is K3D. K3D is a local software developed by Ranger. So first of all, there is Kubernetes. Kubernetes, as I said, it's an open source software. And if you search yourself in GitHub, you can get the open source code, the code of Kubernetes, right? You can go to GitHub and search for Kubernetes. You can find the official Kubernetes GitHub repository. Just search for Kubernetes. And then over here, you can see this is the official Kubernetes. There are more than 1 lakh clicks, commits, changes that were made to the code of Kubernetes. And there are 32,000 people who took a copy of this code, and probably they are trying to make some changes to the Kubernetes code all by themselves. Maybe they have a custom requirement to do that. So this is the original code, and you can download the code by clicking this file. Yes, it is a complicated software. Most probably, if you are not an expert developer, you might not understand most of the parts. But what I'm trying to say is, if you have a big team and you decided that you want to develop your own Kubernetes cluster, you want to add a lot of features to Kubernetes, you want to remove features from Kubernetes, it's very easy. And you don't, but if you are somebody who want to create a cluster, you don't have to learn the Kubernetes source code. It's not important. You can just download the source code as it is, or you can download Kubernetes as it is, and then you can create your own Kubernetes cluster on your premises without worrying too much about the Kubernetes code, right? You don't have to. For installing Kubernetes, there are easier methods available. There are executable files that you can download. You don't need the source code for that. You can just search for how to install Kubernetes on premise, right? Install Kubernetes on premise, search in Google. There are tools such as kubeadmin, various tools available that can automatically install Kubernetes into various machines that you have locally. So that is possible. You can install a Kubernetes cluster or run a Kubernetes cluster all by yourself. It's a free software. Just find the right documentation. There are even automated tools that would allow you to do the installations in a automated way. It's you can complete the installation in less than 15 minutes, and you can create a cluster all by yourself using a bunch of machine that you currently have, and a minimum 3 machines are recommended. So that is one option. The companies can use Kubernetes and create a cluster all by themselves. And then there are managed clusters, managed Kubernetes clusters in the cloud. So all cloud computing providers, whether it is Google Cloud, whether it is AWS Cloud, since Kubernetes is open source, anyone can and they are capable people who can download the source code of Kubernetes and make the customization the way they want it, right? They can directly go to GitHub, they can download this complete code. It's a huge code base, complicated code, right? Which consists of more than 1 lakh changes made so far. So but the cloud computing provider, what they had done is they they got Kubernetes and they customized Kubernetes the way they want, and they configured Kubernetes to work with their internal use. And most of the other services that cloud computing provider provide, such as load balancers, disk, virtual machines, network services. There are various other services that every cloud computing provider provides. So they used Kubernetes to customize Kubernetes in such a way that it can work with those internal services that the cloud provider already provides. So every cloud provider do this. They take Kubernetes code, they make some customization, and they don't make a lot of changes in the Kubernetes core. Kubernetes has various components, various small software components. So cloud providers can just work only on a specific component. It's called Cloud Controller Manager, which they can customize and configure Kubernetes to work with their systems. So anyway, we don't have to bother too much about how the cloud provider did that, right? It's not your concern. But most of the cloud provider today, they allow you to create a managed Kubernetes cluster in the cloud. You can log into your cloud provider, click few buttons, click, and within few minutes you will get a cluster ready. And then every cloud provider also tells you once the cluster is ready, using kubectl you can speak to that cluster. So a DevOps engineer who has kubectl installed, just like he speak to a K3D cluster, he can speak to a Google Cloud cluster, he can speak to an AWS cluster, he can speak to the cluster whichever cloud provider that he is using. So, and that is an option in Google Cloud. It's called GKE, Google Kubernetes Engine. AWS, it's called Elastic Kubernetes Service, EKS. So you can either create an EKS cluster in AWS, GKE cluster in Google Cloud, or AKS cluster in Azure. Right? Most cloud computing provider today, they support Kubernetes because Kubernetes is so much popular, and Kubernetes is today everyone's day-to-day need, right? Most of the company need Kubernetes, so every cloud provider must provide this service, right? Because people want to use Kubernetes, and cloud providers make it much easier by providing a lot of extra services. So what are those extra services? So that would include the load balancers, for example, some load balancers, for example. So assume you have a Kubernetes cluster and you are running your containers inside that cluster. And now you want to receive traffic from the internet, right? You want to receive traffic from the internet. So you have, think about your CoIT front-end application, and it want to receive the traffic from the internet. So AWS, Google Cloud, or AWS, whatever your cloud provider is, every cloud provider has a load balancer service, and that is where your customer should be sending the traffic. The people all over the world, when an incoming connection need to come to a Kubernetes cluster, technically, if it is coming from outside world, then there should be a load balancer that is sitting in the front. And what this load balancer does is it will accept the connection coming from your customers. Maybe they are browsing, maybe they are doing something else. They will always speak to, whenever they want to speak to the application, they will speak to a load balancer. And the load balancer has to redirect the traffic to one of the backend containers that you have inside your Kubernetes cluster. This is how in real time you accept traffic from the customers. There should be a load balancer to which all your customers should be connecting, and then the load balancer will send your customers to one of the pod in the backend. That is how the application receive traffic from customers using a load balancer. So apart from creating a Kubernetes cluster, you may want to create various load balancers. Maybe the front-end application want to receive traffic from the load balancer. The Java application want to receive traffic from the internet. So there may be multiple load balancers that you might need. So, and you want to create the load balancers based on the requirement. So apart from creating the Kubernetes cluster, now you have one more responsibility. You want to manage the load balancers. So you don't have to, fortunately. If you are using the cloud provider has a load balancer and it is already integrated with your Kubernetes service. So as a DevOps engineer, you can specify, I need load balancer as the service. And that's it. Rest of the things, your Kubernetes cluster takes care. Your Kubernetes cluster in the cloud will talk to the cloud provider load balancer service, provision a load balancer, make it ready to accept the traffic from the internet, make it ready to send the traffic to your application correctly. So all these things will happen automatically. All you have to do is, all your DevOps engineer has to do is, when they create a service for this application, they will mention that service type equal to load balancer. This is just an example that I am saying. This is not the only advantage. So later on, you want to do something else. You have a lot of containers and they want to store some important data. So the data should be stored in a permanent place, right? When you have some not stateful applications, they want to store important data. That data should be stored inside a secure place. Even if the container get deleted and a new container get created, right? Kubernetes do that a lot. It create delete container, create containers. Kubernetes do that a lot. So when a container get deleted, what will happen to the data? Right, that is important, right? So the data should not be stored inside the container. Instead, the data should be stored inside a dedicated disk, right? It should be stored inside a disk, and that should be probably, it can be outside the cluster, it can be somewhere else that you have set up, it could be a disk. And if you are using cloud, every cloud provider provide such kind of disk services. It is like a pen drive sitting in the cloud. So when you configure your application to store some data, rather than storing data internally inside the container, you can choose to create a disk in the cloud and store the data. Your container can mount to that disk, and then all the data you can store in that disk. So even if the container get deleted and the new container got created, the data will stay same because data is not inside the container. So you want to do this for your important data. Maybe not all data are important, but think about some stateful application you have. It is storing some data inside the container. Then that is important data. If the container is deleted, the data is gone. You don't want that. So whenever your application want to store some data, it should be stored inside and said permanent disk. So if you are using cloud, you don't have to worry about creating the disk and managing the disk again. You will write it down inside your manifest again. You would mention, I want to create a disk to store my SQL application data, right? And then you just mention that inside your YAML file, and then rest of the things your GKE cluster or your cloud Kubernetes cluster takes care. It provision a disk in the cloud and then mount that disk to the container. So all those instructions you can write inside the file. So that is your job. As a DevOps engineer, you just manage the Kubernetes cluster, and then your cloud provider already did a smooth integration. These are outside services from the cloud provider. These are not internal Kubernetes services. Load balancing, disk, then networking, machine creation. You need lot of machine to run the cluster. So machine creation, everything is outside services of Google Cloud, right? So, but even though they are outside services, you can manage them just like Kubernetes can manage them all at one shot. And as a DevOps engineer, you just write code for everything. When you want a disk, when you want the disk to be mounted to your application, when you want a load balancer, you want the load balancer to be connected to your application. When you want a network, when you want a machine, you write YAML file, you write the decide state and run the kubectl apply command. Then your cluster will do the rest of the action. So this is important for many companies today, and that is why Kubernetes is best run in the cloud unless your company has a specific requirement. Like, assume you are a bank, you have strict compliances that you want to meet. The cloud provider don't meet those compliances, then you have to run it in yourself in your own machines, right? Otherwise you don't have much strict compliances and things like that. Then running Kubernetes in the cloud is probably the best and easiest option for everyone, because the cloud providers, when they create the managed Kubernetes service, they will make sure that all other services that you need are properly integrated with the system, so that you can simply create the cluster and directly manage everything from a single YAML file. I mean, not single YAML file, multiple YAML file. And the point what I mean to say is a set of YAML file. You can write code to manage everything, your infrastructure side and also your Kubernetes side, your applications, everything you can write down inside the YAML file. So this big advantage is a requirement of today. Most of the company nowadays the requirement are very very dynamic. They need a lot of things. They need a lot of this, they need a lot of broadband size, they need to run thousands of containers, and not they have such kind of complex requirements are there today. And a managed Kubernetes cluster is a very very good idea to run your application workloads in the cloud. Great. So let's talk about various environments in your project. So when you are working in a company, You will have various environments that your company want to run, right? There may be a K3D cluster in a developer laptop, or there may be a cluster in the cloud where you want to run some testing, and there may be a cluster in the cloud that is where your customers are using your software. So there can be various environment that a company have, and we will just brief about what are those environments that a company will possibly have. So just think about this, right? Inside every company, yes, the company can have various Kubernetes clusters that you have to remember all the time, right? There may be a local cluster that the developer have in his laptop, a K3D cluster, for example. So why a developer should run cluster in their laptop, provided that the laptop, when it comes to laptop, the advantage is that it's easily accessible by the developer. Whenever developer want to do some development, they immediately want to test something. They don't need to depend on any cloud, or they don't need to depend on any other team. They can locally run the kubectl apply command and test everything. They can do that all by themselves. If the cluster is local, that is much convenient. But the disadvantage is that probably not every laptop that developer uses are capable to run the clusters, right? They might not be able to run the clusters. They don't have enough capacity, or laptop may have CPU problem, memory problem may be there when you are running K3D cluster. So most of the company might want to create a cluster in the cloud, a cluster in the cloud, or a cluster in the premises or wherever. And in this cluster also they want to run some testing. Whatever code your developer have developed need to be tested. First, you should develop containers, and the container you want to run. First, you want to run those containers in the K3D cluster. And if that is working in the K3D cluster, you may want to run further testing inside this cluster. So same container, same application you will test here. And finally, if all the tests are passing, probably this is the cluster that you create for the production for serving your customers. Then your container would start running in this cluster after everything become stable. So this is the approach. This is the various environments that the company may maintain, right? And it can vary from company to company. It's according to their requirement they maintain such kind of things. But there should be at least two clusters. One is local and other one is production, and then that way we can. And again, some people use the same cluster to deploy both a development container and production container. That is also possible. Create one single cluster. Then for testing, we want to run some application. Run your test application in the same cluster. The production application also you can run on the same cluster. That is possible. Even though it is recommended only for small project. For big project, it's not recommended. It's better to have separate cluster for separate environment. But for small project, it's okay. People create single cluster and then run multiple um, multiple environment in the same cluster. That is also a possibility. And then how you develop these containers. That is the question, right? In order to develop the containers, every company maintain a Docker file for every application. There is a Docker file, right? So assume this is your developer. You have your developer. Developer is sitting in his laptop, and this guy is making some changes. What he wants to do is he want to make some changes in the source code. When I say source code, I'm not talking about Kubernetes. I'm talking about your software source code, right? You want to change the style of the website. You want to add a new feature to your application. That's what I mean by source code. That is done by your developers, not your job. So they develop the source code. And every time they develop the source code, a new container need to get created, right? A container, or like call them doc container image, right? That's okay. So you want to create images, right? You want to create images that consists of the latest code that your developer made. And then you store this image in some registry, right? You want to do that. All this part you want to store inside the registry. Whatever image, one image for front end, other image for back end, other image for the shopping cart, other image for the prime customer. So like that, a company will have various applications, and All of them will be stored as images inside a container registry. And in the earliest stages of development, you can assume that these images are not very stable, right? Do you think they will be stable? They won't be very stable because a developer made a code change, and that you can find a number of possible issues, right, inside these images. So you want these images to be deployed into a K3D cluster, or maybe a cluster that is sitting in the cloud, right? Maybe a test cluster. So probably you want to run containers from these images. You want to run containers, and you want to deploy your cluster. You want to deploy your Kubernetes cluster with all these various container images, and then you want to go through a proper testing. You want to do a proper testing, and if everything is working fine, your application is running properly fine in Kubernetes cluster. Maybe your engineers need to do some testing. Most of the time, you want to run some automated testing, right? And after doing a lot of automated testing and manual testing or whatsoever, assume your application has issues, then your developer again has to work and fix the issues, and again new image will be created, new image will be temporarily stored here. Again, it's a unstable image. You will run them inside a local cluster or cluster in the cloud, wherever, and you again do some testing, and this time everything succeed. Then probably these images will be marked as a stage image or something, right? But still, maybe you don't have 100% confidence that they are stable. So maybe what you will do is you'll just run them inside the next cluster where you want to do further advanced testing. Maybe in K3D cluster there are certain things that you cannot do. It does not have capability to create the persistent volume or load balances. So for that, you will go to the next cluster where you will deploy your application, and there you will do the remaining testing, whatsoever needs to be done. And if it is working there also, then probably you will mark these images like CoIT frontend 1.0.0, ready for release, ready for release. This is the shopping cart, not ready for release. So I call it dev. And then this is the CoIT backend 2, not ready for the release. I still call it dev. And whatever is stabilized, I call it with a proper name, 1.0.0 or 1.0.1, like that. And those are the images which would go here. Those are the containers, stable containers that would go to my customer environment. This is where my company run the actual application, right? This is where the applications are actually running in my company. And when my customer browse for my website, these are the cluster. This is the cluster where all those application will receive the request. So this cluster may have lots of machines, right? This cluster consists of 2 or 3 worker nodes. K3D, you run it within your laptop itself. This Kubernetes cluster you may be running in the cloud, but the cluster has very less capacity, maybe total together some 15 CPUs and some 30 GB RAM would be there in this cluster. But in this cluster, there may be 1,000 CPUs or maybe 2,000 RAM is possible, right? There may be a lot of machine that contribute to this cluster, provide resource to this cluster. So in production, no, you might need lot of machine, lot of CPU, lot of memory, lot of customers are browsing your website. Lot of people are using your application. Lot of processing is happening. Lot of data need to be stored and processed. So in production, depending on the company size and depending on the traffic and depending on many other things, the size of the production cluster will be huge compared to the local cluster or the dev cluster. So this is the path that a company need to take to deliver their software application to their customers. So these many stages are there, but something that repeats if you noticed, right? Every time there are few things that keep repeating. What is that? Developer make the code change, right? Developer make the code change. And after code change, a new image need to be created. And after the image got created, the image need to be stored inside a proper registry, and that is where you want to store and distribute your images. And then finally, you want to run them inside an infrastructure, in our case, a Kubernetes cluster. So you want to run these softwares into a Kubernetes cluster. Maybe, I mean, this could be a production cluster, this could be a dev cluster, this could be, this process repeats. This process repeats. Developer is making, adding a new feature, this process starts, right? And then the process end. Maybe in this case, it could be a K3D cluster, maybe. And maybe a developer is fixing a problem, and then he is again making the code change to do that. Again, a new image get created, it gets stored and it get deployed. Maybe this time to a dev cluster. And assume every issues have been fixed. Now you got a clean code, you got a proper code, and that is ready to go to production. So again, you will take the code, create the stable images, you will call them with a proper name, and then you would store them in the registry, you will deploy your production cluster. So these four processes keep repeating inside your company, inside your project at various levels, maybe within developer laptop, maybe in the cloud. This process keeps repeating and you would automate it. You won't do it manually. You don't, yes, a code change has to happen manually. I'm just saying whatever after that, right? After your developer made the code change, rest of the things should happen in a much more automated way. And that is very, very important inside a company. And you should not a DevOps engineer need to spend a single minute for this process. Of course he has to develop this process, which is not an easy thing to do, but otherwise every time the code change, a DevOps engineer should not be doing any manual job. That should not be the case, right? So this is important. You should develop a proper automated system that can manage, and you can not only develop it, you have to continuously manage it also, because the requirement will keep changing, right? New code would come, new application may come, right? So you have to again make changes to the YAML file, you have to make changes to this process. There may be various steps in the process need to be modified, that you may still have to do, of course, but you don't do that when a developer make the code change, right? When he get the code change, all this process should happen automatically, and your developer should get an immediate feedback. That is your responsibility, that is important. So this is done in an automated process, even though in our case we did all these things manually, right? Docker build to create the image, Docker push to push the image, kubectl apply to deploy the Kubernetes clusters, right? So we did it manually, but in real time it could be a Jenkins server that you would have in your company, which will run the stuff. So we'll be learning CI/CD, but this is for your understanding, because otherwise, when I talk about this and talk about that, you will keep getting confused. So let's save that confusion, because we will be covering CI/CD in detail. Until then, you should know that this is not a manual job. This is not a job that to be done uh, by an engineer in front of a computer. No, it should be an automated job, and it keep repeating. It keep repeating in every company, in various environment. It keep repeating. Right. Great. Before we start with the data, separating concerns with namespaces. So basically, I'll talk about namespace. What is a namespace inside a Kubernetes cluster? So I told you, if you have various applications and you want a proper isolation between the application, for example, you have want to test your application in a development environment before you run your application in your production environment. So production environment is the customer facing environment. Development environment is for your team to set up or your tools to run some automated testing. So when you have various environment, it is a good idea that you run one environment in one cluster and other environment in other cluster. That is what you can actually do. So when you do that, when you run separate environment in separate clusters, that can increase the cost. When you create multiple clusters, that can increase the cost. So it may not be very practical, or the company would not like, the small teams might not prefer that. So no, in such case, you want to use the same cluster, and in the same cluster you want to run both application. And also that is only one use case. The other use cases are you have various application which belongs to various customers. So in that case, you want to run the applications in. You don't want to create a separate cluster. You want to create a single cluster, and then within the cluster, you want to create isolated spaces. So you might want to do such kind of things, or maybe there are cases the same application you want to run for multiple customer. So you will run one application, same application for one customer, and then you will create a replica of the same application and run it for the next customer. So same application, multiple customers, and for each customer you create a separate deployment. So that is also possible. So due to various reasons you want to separate the concerns. And also sometimes inside your Kubernetes cluster you have some monitoring softwares running. Then in a different place you have your production application running. You want to isolate them, right? The monitoring software, let them run in one place, then some other related software you run in other place. So it is possible that inside Kubernetes you don't have to create a separate cluster to do this. Instead you can create a single cluster and you can create namespaces within the cluster. Namespaces will provide a logical isolation between your various applications that you run on the same cluster. So that is what namespaces are all about. So let me go to the Kubernetes cluster. And if you have one Kubernetes cluster, what you can really do is you can actually split the Kubernetes cluster into various namespaces, and then you can choose which application you want to run in which namespace. It's up to you, right? So you can split your entire Kubernetes cluster into small small sorry small logical clusters. Whatever. So what I'm trying to do is I'm just trying to split it into various small clusters. So yeah, technically that is possible. You can actually have clusters split into small logical units. That's what namespaces are, right? So that's the idea. So this is one namespace and this is another namespace. Like that, you can split into create a lot of namespaces. And even if you don't create any namespace, there is a default namespace. That is where all the applications are getting created. Something that I didn't tell you yet. Technically, every time you create a Kubernetes cluster, there are various namespaces available. And then whatever application that you run inside Kubernetes, you can choose in which namespace you want to run them. And I'm going to show you a command. There's a command called kubectl get namespaces. There's a command called kubectl get namespaces. When you run this command, it would show you all the namespaces what you currently have. So there would be multiple namespaces actually. There is a namespace called default. There is another namespace called could be not list, could be public, could be system. So, and in each namespaces, various applications are running. So in default namespace, some application may be running. When you run the command kubectl get ports, this is how you can choose. I want to see all the ports running inside the Kubi system namespace. I can do this. Kubectl get ports, then minus namespace. That's what, or minus n is also fine. So if you do this minus namespace, then you specify the name of the namespace. Then what the kubectl get port command does is it would show you all the ports running inside this particular namespace. So you can see there are many ports that are running in this particular namespace. Or if you want to see, let's take a look at the all namespaces once again. Kubectl get namespaces. There's a default namespace. So let me check what are the ports in the default namespace. I run the command kubectl get ports minus namespace default. Currently there is nothing, no resources found in the default namespace. Now I'm going to create some resource. In my laptop I have a simple deployment, the CoIT front-end application deployment I have in my laptop, and I'm going to create it. I'm going to run the command kubectl apply -f CoIT front-end deployment. CoIT front-end deployment. I'm running this command. I'm just creating a deployment. So, and I mentioned how many replicas. This is my laptop where I have my Kubernetes YAML file. I mentioned 4 replicas, so it would create 4 ports. Now I run the command kubectl get ports minus n default or minus minus namespace default. Then this kubectl command would print me all the ports running in the default namespace. And even if you don't put this option by default, it is default, right? So even if I don't put this, you simply run the command kubectl get ports. By default, it would show you the ports running in the default namespace. So even if you don't specify the default namespace, by default your resources are created in the default namespace. So and you can work on any namespace that you want. If you want to see the resources in a different namespace, you can replace the namespace with a different thing. So it's up to you. So when you create a resource, you can also choose in which namespace you want to create it. So when you run the kubectl apply command, now let me create a service. This is my CoIT frontend service. I have the CoIT frontend service over here. Now I want to create a service inside the Kubernetes cluster. The command is kubectl apply, right? And at the time of kubectl apply, I can specify minus minus namespace default, then minus f, then I can specify the file name. So this command, what it does is the service get created, but the service get created in whatever namespace you mentioned over here. So right now I mentioned default. So if you want, right? So now you run the command kubectl get services minus minus namespace default. You can actually see now a service got created in this particular namespace, and it is created as a load balancer service or whatsoever. So it's done. And if you want to create a namespace, so again let me run the command get namespaces. These are the namespaces that are available. So now I have decided that I have a new application that I want to deploy to my Kubernetes cluster, or maybe I want to deploy my stage environment or development environment, not production. So maybe production I want to run in the default namespace, but the development test environment I want to run in a development namespace. So you can create a new namespace if you want. The command is kubectl create namespace. This is the command that you can use, create namespace followed by the name of the namespace that you want to create. So let's call it develop. So I want to create a namespace with the name develop. So this simple command would actually create a new namespace. Now we can run the command kubectl get namespaces. You can actually see the new namespace that got created. Now I want to create a Kubernetes service inside the develop namespace. The command that I can execute is kubectl apply, then minus minus namespace develop followed by minus f. Then I can mention the service CoIT frontend service YAML file. So what this command does is it would create a service in this namespace. So let's run the kubectl get ports command minus minus namespace develop. So basically what this command does is it would show me all the ports in this namespace. There is no ports actually. Let me try to create get the list of services. I already created a service just now. So I'm expecting it would show me. Yes, you can see the service got created in the develop namespace. So basically, whether it is service, ports, deployment, whatever it is, at the time of creating, at the time of running the kubectl apply, you can choose to which namespace you want to deploy your application. Or when you want to get the list of services, you can run the command kubectl get with the namespace option. So this way, within the Kubernetes cluster, you can create various namespaces, and then various applications that your company have, you can put them into different namespaces. That would provide a proper level of isolations. And if your application is running in namespaces, you can use the same name. You can even use the same name for your applications. For example, if you have two namespaces, assume you have two namespaces. Assume you have two namespaces within the cluster. And then here you have a CoIT frontend service running. Here you have a quite front-end service. Here you can have, yes, you can have the same exact name of the services and they will not conflict, right? Somebody tried to talk to CoIT backend 1 or CoIT backend 2 within this namespace, they will always reach to this service. Somebody within this namespace want to talk to an application service, they will talk to this service even if the service name are same. So uh, namespaces allows you to deploy the same application into various spaces, even with the same name, exact same name you can use, and still they will not conflict because whatever containers are there in this namespace, when they try to speak to the service, they will always speak to the service within the namespace using the service name. So every service that you create will have a name, and that is the name every container uses to talk to the service. And the container within the same namespace talk to the service, they will connect to the correct service. And again, assume the same name you had given to this service in the other namespace. Then some other pod in that namespace is speaking to the service. They will always speak to this service. They won't speak to the other service. So this way, it allows you to have even various names because you might want to do this because inside your laptop, your YAML files, you already predefined the names of the services, name of the deployment, name of the pod. Everything is already predefined in the YAML. So same set of YAML, you have same application, quite front application you want to deploy to one namespace and other namespace. You use the same exact same YAML, and along with the kubectl apply, you simply use minus minus namespace tag to choose which namespace you want to deploy. So this is much convenient. There is no change of YAML file that you need to do when you want to deploy the same application across multiple namespaces. So that way you can separate the concerns, or you can run some application in one namespace, other application in other namespace based on the project requirement. And this is a very important requirement that every companies will have. They want to keep on creating uh, they want to isolate applications because of various reasons, because of the environment, dev environment in one namespace, production in another namespace, or maybe some application in one namespace, remaining application in other namespace, or maybe same application in various namespaces you want to run because your customer needs it. So depending on your project scenario, Kubernetes allows you to isolate the concerns by creating various namespaces for various applications that you want to run. Great. The data management, maybe, yeah, maybe an important topic. By this we will wind up. So let's talk about how do you manage your data. So, like I said, there are various cluster solutions available. There are Kubernetes clusters that you can create in the cloud, Kubernetes cluster that you can create in the K3D, Kubernetes cluster that you can set up yourself on your premises using various free softwares, automation tools. It's possible. So I'm just talking about a cluster that you want to create in the cloud, right? Throughout our training, we'll be talking about cloud clusters, not other clusters. Most of the time, we'll be also talking about K3D a lot, and we'll also talk about, most of the time, we'll be talking about a cluster that you create in the cloud. And then you have your container. You have a container running inside the cluster, one or multiple containers. And this container want to store some data. This container want to store some data. And if the container get deleted and recreated, yes, Kubernetes do it a lot of time. Kubernetes delete your container and create your container again. Or sometimes the container itself get crashed. Kubernetes recreate it. Sometimes you want to do a rolling update. You have a new version of your application has come. The current version is you are running 1.0.0. Now you want to roll out 1.0.1. So in that case, you ask Kubernetes to do this. Kubernetes will delete the old pods, and then Kubernetes will recreate the create the new pods with the latest application version. So this is so the point what I'm trying to make here is that your pods keep on getting deleted and new pod may get created, and so Kubernetes is designed in that way. Whenever there is a situation, this is what Kubernetes do. When you want to make any change, this is what Kubernetes do. When your application crashes, a Kubernetes container get killed and a new one get created automatically. So always remember, containers are the pieces that that are supposed to get deleted and recreated, and you should be okay with doing that. Right? That's very important before you start thinking about your application running in Kubernetes. You should take care of such kind of things. Your application should is okay to being terminated and being replaced with a new one without downtime. Right? That should be okay for your application. That's important. So that's something you have to take care from the application side. But anyway, the point what I'm trying to make here is that the container may get deleted and new one get created, and that happens continuously. So assume you are running some stateful applications. What that means is you are storing some data. You are storing some data. Your application is storing some internal data. For example, your customer upload a photo on your website, and then your application get the photo and store that inside the container, and then a new customer upload a new photo, that photo also need to get stored. So assume your application is storing something, some data is being stored inside the container, or some caching is happening inside the container. So at the end there is some data that reside inside this container, and if Kubernetes delete this container and create a new one, then what will happen? Or assume for some reason container get crashed, what will happen to the data? Because there are some important data that my application stored inside the container. That data will be lost, right? And I don't want the data to be lost. So what you have to do is such kind of containers that want to store some state or some data, you would put them inside, you would put that data inside a disk. I mean, technically it is the container, but you will mount the container with some disk. And if you are using the cloud provider, every cloud provider support various storage devices, right? Uh, like fast disk, slow disk, the disk that can span across the entire cluster, the disk that can span across a single availability zone. There are various kind of disks that you can create in your cloud providers today. Whoever your cloud provider is, everyone provide disk services, and it can be mounted. So you can create a disk and you can configure your container to mount to that disk whatever specific folder. For example, www.html folder, or some specific folder where you want to store all the data. You can mount that folder to a disk, so that even if the container get deleted and recreated, the new container www.html folder will have the same data, because the data is stored outside and it is mounted to the container. Whether you delete it or create a new one, the data will still persist. I mean, that folder will still persist, because that folder is actually mounted to some disk that is sitting in the cloud. So this is how you want to maintain and manage your data, and that's very very important. And if you are using cloud, you would be using some cloud disk, whichever disk supported by your cloud provider. So that is how you should be managing your data when you are running some stateful application that want to store some data when the application run. So that's the whole point. And then I will quickly demonstrate this to you today. I will create a persistent volume inside the Kubernetes. That is another resource in Kubernetes that you create to manage the data. And then I would configure my container to claim the disk, claim APV. So yeah, that's what we will do next. I'll just try to complete it in 15 minutes. Sorry for that. So let's try to do that. So I'll talk about what is a persistent volume and what is a persistent volume claim inside Kubernetes. So, like I said, Kubernetes is a open source software, free software, and it is not specific to Google Cloud. It is not specific to AWS. It's not specific to any particular cloud provider. It is modular and it is extendable. It is flexible, and whether you are using an on-premise data center, Kubernetes still allow you to use whatever disk solution that you use in your data center. Or if you are using Google Cloud, then whatever disk that Google Cloud support, Kubernetes supports them. Whatever you are running using AWS, and then whatever disk AWS support, Kubernetes should support that. So Kubernetes is a free software, and it is developed in such a way that it work with various other systems. uh, Not only data storage system, load balances, very many other things. So today we are going to talk about the data management. So Kubernetes is designed in such a way that it can work with various data providers, Google Cloud, AWS, or even on optical fiber devices, or it could be NAT storage, network storage. Various storage solutions are available today. Kubernetes is integratable, or Kubernetes can be configured to work with any storage solutions that you are currently using. And if you are using cloud, the best storage solution, most probably what you are using would be the disk in the cloud, and that is what today we will be talking about. So Kubernetes provides some CSI plugins that run inside the Kubernetes cluster that would allow various providers to integrate their storage solutions with Kubernetes. And that is what it is. So in case of Google Cloud provide a disk service, and you can create a disk inside the Google Cloud. So if I log into my Google Cloud account, I can do it from the UI also. Uh, Google Cloud allows me to do that from the UI also. I can create a disk, and then I can attach the disk to a virtual machine that I create in the Google Cloud. But I'm not creating any disk or attaching. I just want to show you this, the possibility. So I'm going to log into my Google Cloud account, and then you can search for disk in the search box. You can search for disk, and this is a storage solution provided by the Google Cloud. Okay, this is a storage solution provided by Google Cloud. So there is disks available. I can create a new disk if I want by clicking the create new disk button. This is the disk page where I already have a number of disks created, and I can create a new disk also. It's a bit slow. Yeah, I can click this button to create a new disk. Then I can choose what is the size of the storage that I want. So it's like a pen drive in the cloud, right? It's like a pen drive in the cloud that I can create just by clicking few buttons. I can choose where I want to create it, in US or in Mumbai. I can choose that. Then I can choose the size, 100 GB or 10 GB or whatever. 10 is minimum. So like that, I click on create button, a disk gets created, right? And then I can configure that disk to my pod. But when you are using Kubernetes, you don't want to do any manual job, right? You don't want to create a disk. You want the disk to be created automatically if your application needs it, right? So Kubernetes is a platform as a service. Whenever you need something, you ask Kubernetes that I need that, and Kubernetes gives you that. And that is how Kubernetes works most of the time, right? It does not want you to do any manual job. When you want to create a disk, when you want to attach a disk to a container, when you want to do such kind of things, it should happen automatically in the background without you worrying too much about it, right? That's the way how it should be. So let's take a look how Kubernetes is designed to work with the disk. That's what I'm going to talk about. So like I said, Kubernetes has various CSI plugins that no, one of the plugin is configured to work with the Google Cloud. Google Cloud, it can speak to Google Cloud. It can manage the disk, or you can provision the disk in the Google Cloud. Then it need to know what kind of disk it need to provision. So when you create a disk, there are various options available. There is SSD disk. There is disk that has a slow bandwidth. There are various disks available, a balanced disk, SSD persistent disk, extreme persistent disk that has very fast storage. So various options are available. So based on your requirement, your application requirement, you want to choose which type of disk that you want to create. Google Cloud provide flexible options. If you need slow storage, you can go with the balanced persistent disk. It provide moderate speed, but it is not good for your high transaction databases. It's not good for high transaction data processing. No, it is good for general purpose. But if you have a high transaction database, maybe you should go with the SSD persistent disk, or extreme persistent disk. So it's you decide. You decide what kind of disk you want. But Kubernetes, technically, you want to tell Kubernetes that, right? What kind of disk to be provisioned in the Google Cloud. So basically, what you do in Kubernetes, you create a storage class. you create a storage class to define various kind of disk. You can create one storage class called SSD, another storage class called normal persistent disk, another one called standard persistent disk. So you can create various storage classes to match various disk solutions that Google Cloud support, and then you can associate your volumes with that particular storage class. So a storage class in Kubernetes, if you created a Google Cloud cluster, a storage class would be already created for you. So right now I'm working on a Google Cloud cluster using kubectl, and right now in my laptop I'm running a kubectl command, kubectl get storage class. So by default, even if you don't create any storage class, by default, when you create a Google Cloud cluster, some storage class would be already created. I just want to see them. So there is a storage class called premium read write only, standard, then standard read write only. There are three storage class that got created. And then over here, I can see the provisioner. This is the plugin that can provision a disk in the cloud. So various, these are various provisionings that you can use that Google Cloud support, Kubernetes supports, and things like that. So let me show you. Let me open this storage class and let me show you this, right? Uh, and in order to do that, I can use the same kubectl get command, kubectl get storage class. Then I can specify the name of the storage class. So in this particular case, a standard, and that is the default storage class. Every time I try to create a volume without specifying storage class, this is the default one that would be used. But right now, I want to examine that storage class. I want to see how it look like. There's a command called get storage class minus o YAML. When you put minus o YAML at the end, Kubernetes would print the current status of this particular storage class. And you can see a YAML file. So it looks like a normal Kubernetes YAML file. And there is one thing that you need to make note. Provision is GCE PD. And you can get this information from the Kubernetes documentation. What is the provision for Google Cloud Persistent Disk? So this is the provisioner. And then what is the type? PD standard is there, PD SSD is there. So you specify the type, and in this case, it's PD standard. So this is one storage class, and like this, if I want to define more storage class, let me define a storage class all by myself. Storage class Google Cloud SSD.yaml. I'm going to create a storage class all by myself. I just copy paste this and then I modify. I'm removing all these lines, which is unnecessary. I'm going to change it to PD SSD. And provisioner is same, GCE PD, provisioner is same, otherwise not change. I just save this file, and now I run the command kubectl apply minus F. Now what I'm doing is I'm creating a new storage class. Okay, I didn't change the name. I'm changing the name to standard SSD. The name of the storage class I'm changed to standard SSD. So what I'm doing is I'm creating a new storage class with the name standard SSD. So it is possible. Kubernetes allows you to create various storage classes. Now you run the command storage class, get storage class. You can actually see the new storage class that you have just created, standard SSD. So this way you can actually have various storage classes create. So one storage class, talk about creating an SSD disk in the Google Cloud. Another storage class talk about a standard disk in the Google Cloud. So like that, various storage class solutions uniquely identify what kind of disk that you want to create in your provisioner. In this particular case, the Google Cloud, and this is the provisioner name. When it comes to Kubernetes Google Cloud, when it is AWS, it's something else. I think AWS EBS or something. So it will change based on your cloud provider. In case of Google Cloud, this is the value. Great. So I created the storage class, and basically storage class won't create any disk or anything. It only consists of the specification of the provisioner. That's it. Now the next part, we are going to create the PV, persistent volumes. That's what we will do next. And when we create a PV, you can choose which storage class that you want to use. Either you want to use standard, you want to use SSD. So respectively, Kubernetes will create a respective volume in the cloud. If you choose this storage class, it would create a necessary volume. If you choose this storage class, it would create a standard volume. So that is the purpose of storage class. You define them, and later when you create the volume, you can choose which storage class you want to use. Great. Is it confusing? Is it clear? So basically, storage class is nothing but it defines the disk, the underlying technology that you use. In our case, it's Google Cloud. So it talks about the provisioner name and also the type. Two things we mentioned mainly. So that's all. That's all you have to do. So we discussed about storage classes, right? Storage class. Now let's talk about the persistent volume and persistent volume claim. So let's next we'll talk about PV and PVC. So creating storage class is a one-time action. So assume you are using Google Cloud. First, you will define various storage classes because your plan is to run different application. It may be some high transaction database, maybe some normal application that don't need fast storage. So you would be defining a lot of storage class. You will keep them, and later on you would use them when you want to provision a volume, right? You may want to provision a volume for your database. Maybe that could be an SSD volume. You want to provision a volume for your other application, that could be a slow volume. So you might want to create and provision and use different disks based on your application demands. So that is the way Kubernetes works, right? When you need a disk, you create it, and when you are done with it, you delete it, right? Kubernetes is always focuses on a platform. Kubernetes is technically it's platform as service. When you need something, you define, and when you are done with it, you delete. And that's the way how Kubernetes works. So let's talk about our application. Let's consider the application, the CoIT frontend. CoIT frontend, assume the www HTML folder in the CoIT frontend container. I want that to be created in a PV. So first of all, I want to create a PV, persistent volume, inside the Kubernetes, which is nothing but in this particular case, it's a disk in the cloud. And not only that, I want to create a PV, and I don't want to create a PV manually. If I want to create a PV manually, Kubernetes has a YAML file. A PV can also be defined as a Kubernetes manifest. You can create a PV, and then you have to tell the PV what is the disk name in the underlying Google Cloud. So you have to create a disk in the Google Cloud. Then you have to create a PV in the Kubernetes cluster, and then you have to associate them. For that, you have to put some settings in the PV, and then your container can mount to that PV. This is the actual process if you want to do it manually. But no, you don't want to do it manually. That's not your job. Especially when you're using Kubernetes, you avoid manual jobs. You want the PV to get created automatically if it is not present. If it is already present, you want to mount it. So the way how you want to do in Kubernetes is that when a CoIT frontend container get created, or when your application get created, started inside the Kubernetes cluster, it will ask for a PV, or it will claim for a PV, which we call a persistent volume claim. That's what your application should do. Your application should request for, hey, I need a PV. So it will make a claim and to a PVC that you predefined in Kubernetes. So you will create a PVC, and what this PVC is, PVC is associated with a PV. Every time you create a PVC, a PV also get created along, and then when your pod get created, pod will make this claim. Call this PVC. Hey, I need the PV. So if the PV is already there, it get mounted to the container. If the PV is not there, it gets created in the Google Cloud as well as in the Kubernetes cluster. So that's what PVC is all about. So PVC manages the PV, create the PV, delete the PV, manage the PV, or associate the PV with the respective container. So that's what PVC will do. You can consider PVC more like Your deployment manage the pod, right? Same way, PVC manage the PV, persistent volume. And it doesn't matter what is the underlying technology. So when you define the PVC, you would mention what storage class that you want to use. That also you would mention what kind of storage class you want the PV to be provisioned with. So all those information you would mention at the time of creating PVC. So that's what I will do. I will create a PVC inside my Kubernetes cluster. Again, that can be created as a that can be created what as a Kubernetes resource. I can create a YAML file for that, and then I will create a PVC. And later, my CoIT frontend container, when CoIT frontend container startup, it will call this PVC. So I have to modify. First, I have to create the PVC. Let me create the PVC first. That's what I'm going to do. Let me create the PVC first. I go to the code in my laptop. Under the resource manifest folder, there is a folder called PVC. And if you go to fast PVC, okay, over here, take a look. So I have this uh, resource defined. The name of the resource is CoIT frontend fast. And this is the kind, no, persistent volume claim. I'm going to create a persistent volume claim inside my Kubernetes cluster. Great. That's what I'm doing. And now let's look at the spec. So you specify read write once and you specify what is the size of the PV that you want to create. And then you mention what is the storage class. I'm going to mention its standard. There is already a storage class called standard, and that is the storage class that I want to use. All right. So great. So this is the current situation. I defined a PVC, and now I'm going to create a PVC inside the Kubernetes cluster. So in my laptop, I'm going to run the kubectl command, go to the folder PVC, and this is the file, fast pvc.yaml. Yeah, this is the file, and it is defining. This is the storage class it's using. It's creating a 8 GB disk. That's what I want to do. So go ahead and run the command kubectl apply -f, then the YAML file. So what happens is a PVC got created. Now you run the command kubectl get ports. You can see the, sorry, not port, kubectl get PVC. Now you can see the PVC got created. Great. And also a PV got created, a persistent volume also got created automatically. You can run the command kubectl get PV. You can see a persistent volume also got created that satisfy the PVC settings, right? 8 GB volume, read write only, right? All these settings. So automatically the PV got created. So I'll repeat once again. What I just did is I created a PVC, and in fact, it created a PV as well as a disk in the Google Cloud. If I go to the Google Cloud, go to the disk page, since this is a managed cluster, the disk is automatically integrated with your Google Cloud. And if you refresh the disk page in the Google Cloud, you would notice that a new disk got created inside your Google Cloud also. That is perfect, right? A new disk got created inside your Google Cloud, and you can match the disk by by using this name. Over here I can search for this name, right? I can go to the cloud, I can search for this PV name, then you would find some matching PV disk created over here. It's 8 GB size, and it's in, you can see it's a standard persistent disk. That's the storage class what we used. So automatically the disk got created inside the Google Cloud. Perfect, it's done, and the disk got created inside your Google Cloud. So technically, I created a PVC, and internally it created the PV as well as the disk. So it's done. But so far my containers don't have any relationship with the PVC, right? I mean, container has to claim the volume. Container want to ask, hey, PVC, get me the PV, right? Container ask for the PV to the PVC. Then PVC will look if the PV is already there, then mount that PV to the pod, right? Or make that PV available to the pod. So that's how your application will get access to this disk. Right now, the PVC is there in the Kubernetes cluster, and this is a independent unit. Now you want your application to automatically get the disk from the PVC. That's what you want to do next. So let us do that. How we will start our CoIT front-end containers, and when the containers start, it will automatically claim the volume. So let's see how that will work. That's what we will discuss next. How your application will claim the volume. That's what we are going to discuss next. So we already created the PVC. Now your application or your container want to claim that VPC. That's what you want to do next. Claim the VPC, and then it would get a PV, and it would define a volume, and then that volume need to be mounted. So these many steps needs to be done. So I go to the code, and I will go to the CoIT front-end deployment YAML file. That is the file I need to edit, right? That is the file CoIT front-end deployment.yaml. And this file currently consists of these settings. And what I am going to do is I'm going to specify something called volume under port spec. You can specify containers. Just like container, you can specify the volumes. So I'm going to specify the volume. You can simply specify the name of the volume. Give any name that you want. What is that? Apache document root or Apache root. Give some name, or Apache root or Nginx root. What? Nginx root. So I call it Nginx root is the name of the volume that I am defining for the port. And over here, I have to specify something like this, persistent volume claim. And then I have to specify the name of the PVC that I just created. So for that, first I run the command get PVC. And this is the PVC, CoIT front-end fast. That is the name of the PVC that I just created. And I am going to specify that name over here. So basically, I am asking my pod, the CoIT front-end pod. This is nothing but the CoIT front-end pod deployment YAML file. I am asking my pod that you just call this claim, and whatever volume that you get in return, you define it as a volume and call it Nginx root. And then this Nginx root volume, whatever it is, mount it to the folder www.html within the container. So that's what you want to do next. So go to the containers, go to the container session, and under the container session, I want to add a new line called volume mounts. Volume mounts. So two things. One is the mount path. I can mention, let's say, www.html. This is the folder in the container I want to mount. And what is the volume? This is the volume and Nginx root, whatever volume that I just claimed, right? So this is how you add your claim settings. First, you should define a volume block to define a volume that the pod will claim. And then once you have the volume, you will mount that volume to this folder in the container, the www.html folder. So this is exactly what you have to do on your application side or in your deployment YAML file. This is what you have to do to get this volume from this claim and mount that to your container on the location, whichever location that is important to you. In my particular case, I want the www.html folder. That is where my application store data, and I want that data to be stored inside my Google disk. So this is how, these are the settings using which a pod or your application will claim the disk, the PV. So let's do that. Let's try to redeploy your application. Same application, I can again run the kubectl apply command against the same file. Then it will automatically modify my application. Kubectl apply -f followed by CoIT front-end deployment. So I already have the CoIT front-end deployment. I already have pod running, right? So this pod will be deleted and recreated with the new settings. That's what Kubernetes will do. I already have CoIT front-end pod running in the cluster. Now I am making some change. The pod want to claim the disk. So you cannot do it on a running pod. So what Kubernetes automatically detect is that There's a pod already running. Kubernetes will delete the old pod, create a new one with later settings, whatever I mentioned, the volume claim settings. So run this command. Oh, okay. Nginx root not found. What is that? Where is that? It's giving me an error. Name is nginx underscore root. And then I am mounting this here. And it is throwing me an error that spec contains volume mounts name not found. I think I have to delete and recreate the deployment. Let me, because I changed the volume settings. Most probably I have to delete the deployment. Deployment is deleted. Then now let me try to recreate the deployment. No. Okay, sorry. Yeah, it has to be. It's the name. It should not contain underscore. Sorry for that. So here I'm putting minus instead of underscore, hyphen instead of underscore. That was the problem. Sorry for that. So that is solved. Now let me try to do this. And it's done. The pod is created. Kubectl get pods. You can see contain this. It's being created. It won't take much time. It's running and the pod is in running state. But this pod, when it got running, what happened in the background? What happened in the background? When the pod got created, it made a claim and it got the PV. The PV got mounted to the www HTML folder, or this Google Cloud Disk is what that is currently mounted on your container on the www HTML. Makes sense? So let me show you. Let me prove this to you, right? What I'll do is I'll go to my command line and I'm going to add some container. First of all, let me log into the container. Using kubectl exec command, you can actually log into the container. Kubectl exec -ti followed by the pod name. Then our pod consists of only one container. So if I execute the bash command, then I would get the command line of that particular container. So now I am inside the CoIT frontend container. This is my CoIT frontend container. I'm logged in as the root user. I'm currently working as the root user inside the container. Let me go to the www.html folder. Now I am inside the folder www.html. It has only one single folder. Let me create a new folder and let me also create a new file and let me add some content into that file. Test content. I'm adding some content into this file. So basically, what I did is I manually use some command, touch command and mkdir command to create a file and a folder inside this pod, right? Great. So that's it. I am going to log out from the pod. Exit. I'm going to exit from the pod. Now I came out of the pod and the pod is still running. What I'm going to do is I'm going to delete this pod, right? I want to delete this pod. Remember, inside the container, I created a folder and a file. And now I am deleting the container or the pod using the delete command, kubectl delete command. You can delete a pod, kubectl delete pod followed by the pod name. Now the pod got deleted. Pod got deleted, right? So technically what happens is the pod get deleted. And what will happen if the pod get deleted? Will it get recreated automatically? In our case, yes, right? We already created it as a deployment. So even though you delete the pod, a new pod get created automatically because Kubernetes, remember, Kubernetes has that internal mechanism to automatically recover the problem. So we created the deployment, which is a controller. So whenever something get deleted, Kubernetes recreate automatically, right? You know that. Great. So what would happen now is if you try to delete a pod, Kubernetes will automatically recreate a pod. Now let's see what is the latest status. Yes, a new pod got created, right? 43 seconds ago, a new pod got created. Perfect. Now I'm curious what happened to the data, what happened to the folder and the file that I created inside the www.html. Let's see. I'm going to log into the new pod using the kubectl exec -ti. Then go to the new pod, go to the www.html. So what will happen to the data? Data is still there. Test.txt is there. F1 is there inside test.txt. It has the content whatever it was created before. So everything looks good. Your data persists, right? Even after a pod recreation, nothing happened to your data. Your data is still there. And this is what you want to do to your important data. Because Kubernetes keep deleting and creating containers. That's what Kubernetes do. Kubernetes want to do that for various reasons. When you do a rolling update or when a node crash, when your application crash, Kubernetes has to recreate a container or pod or whatsoever. And the newly created container should have the same data, whatever the old pod had. And this is not the case all the time. This is the case sometime when your application want to store a persistent data, but not every application are stateful, right? Many applications are stateless. They don't care about data. They run it, they run some process, and even if you delete it, there is no data that is left on those, they may be recreated. I don't worry. But those applications that depends on data or store data, I want to make sure that it is stored inside persistent volume. That is important. All right, so this is how you manage your important data when using Kubernetes.